So far in Chapter 19, we've looked at magnets and magnetic fields. Now I'm moving on to Section 19.2, which covers magnetism from electricity. Here's a simple diagram for a wire carrying current, or electricity, which we write as I. When a wire carries current, it has a cylindrical magnetic field, which we label B, as I've drawn in this diagram. We say that this magnetic field is induced by the current, and when the current is reversed, so is the magnetic field. In order to calculate the direction of current and magnetic field in a wire, we use what's called the right-hand rule, which is a rule that applies to the motion of your right hand. So in this image, I've used my right hand to calculate the direction of the magnetic field on a wire where the current is flowing up, as I drew to the right. So the way that the right-hand rule works is you point your thumb in the direction of the current in the wire, which I've used a straw to represent in the picture. Then the way that your fingers curl, which in my case is this way around the wire, is the direction of the magnetic field. So for the wire in the diagram, the magnetic field would be pointing this way around the wire in a series of concentric circles. The right-hand rule also works for current-carrying loops, which are substances that carry current similarly to straight wires. So if I were to draw the magnetic field on this loop to the left, the arrows would point this way similarly to how they would in a straight wire, and circle around in a series of concentric circles. Similarly, if I drew this wire with north and south ends, the current would also flow around in this way, forming a magnetic field. Current-carrying loops are important for making stronger magnetic fields. In objects called solenoids, which are tightly wound coils of wire, these current-carrying loops are used to create a greater magnetic field. Here are some practice problems. Number 1. What is the shape of the magnetic field produced by a single current-carrying wire? So they're asking about a wire that's carrying some current through it, and what shape the magnetic field would make. So as you saw in previous diagrams, magnetic fields form a series of concentric circles, or almost a cylinder, around a current-carrying wire. Number 2. In what direction is the electric current in this wire flowing? So in this situation, you would want to use the right-hand rule, which is a little bit hard to demonstrate on this screen, but if you were to wrap your fingers around this way, in the direction in which the field is moving, your thumb would stick out towards the bottom of the wire. That means that the current is flowing this way. Number 3. What is the direction of the magnetic field in the wire? So in this case, we're using the right-hand rule again, where your thumb is pointing up this way in the direction of the current. This time, your fingers would wrap around this way, meaning that the magnetic field is moving in this direction around the wire.